Today we're going to be learning how to use the OnReady and WhenReady design pattern. This is commonly used for API design and other asynchronous operations. We're going to start by opening up Xcode, smashing that like button down below, and creating a playground. So we're going to create a playground, we're going to take a look at the design pattern and get a good glimpse of it, and then we'll create an actual Xcode project, and we'll get into the weeds of seeing a real world example. So let's go ahead and create a blank playground here. I'm going to call it OnReady Fundamentals, and if we spell it incorrectly, that's okay. Let's go ahead and expand our Xcode window, and let's talk about this design pattern. So the design pattern kind of gives itself away by its name. You want to call a function when something else is ready. So how do we do that? So let's go ahead and create a class, and maybe we'll go ahead and call it API caller, since this is a common use case. And perhaps we'll say that we have a shared instance of the said API caller class. So we're going to have a static constant, and I'll go ahead and privatize the initializer so all callers go through this shared instance. So let's say we first need to go ahead and perform some type of warm-up operation. So let's go ahead and create a function called warm-up. Now, in our hypothetical example, we're not going to actually implement this, but let's say we want this warm-up to finish. And once it's finished, we then want to go ahead and call, any other subsequent operation. So let's say we have another operation of get data. And get data is going to basically take a completion handler, and once it has got the data, of course, it's going to come back and tell our caller that, hey, here's the data. So it's going to return data. This completion handler will be escaping, and it's going to return void. So how do we go about doing this whole when ready business? So let's go ahead and create a private var in this class, and we're going to say is ready, and by default is ready is going to be false because we haven't necessarily finished warming up yet, whatever warm up means to you. So let me go ahead and down here we're going to create a instance. I'll go ahead and say that this is API caller dot shared, and the first thing we want to do is say API caller dot warmup. Now let's say in our warm-up function, our warm-up call is going to take, something like 5 seconds. So we're going to artificially say async after, we're going to say now plus 5 seconds. After 5 seconds have elapsed, we're going to go ahead and say self.isReady is now going to be true. So now that it's true, we can start to go ahead and do this getData function. However, what happens if getData is called prior to the fact that isReady isn't ready yet? It's not true yet. How do we handle that? So let's actually see that example in action. So here I'm going to go ahead and say API caller dot getData. And let's say in here, instead of making it a actual data, let me just go ahead and make it a string for the sake of simplicity. I'll go ahead and make this string, and for each of these, I'm just going to go ahead and print out whatever string is passed back to us. So what we want to go ahead and here and do is we're going to say guard is ready. If we're not ready, we don't want to even try to perform whatever operation we're about to do. So if it is ready, we're going to go ahead and say completion and pass back was ready. But now we want to handle this special case. And this special case might look a little kind of complicated, but it's really not. All we really want to do is hang on to this completion handler until we are actually ready to go ahead and use this getData function. So we're going to go ahead and grab this closure, the type of this closure, and I like to use a type alias. It makes readability better, so we'll go ahead and call this type alias. This is going to be completion, and I'm going to stick that there. This is going to become an escaping completion block, and we're going to have a private var of blocks on here, and blocks is going to simply be an array of this completion type that we have created. And that's not completion, that's comparable. We'll go ahead and say completion. And in here, what we want to now go ahead and do is say blocks.append, and I'm going to go ahead and append the completion. Now, you might be wondering, what is the benefit of doing this? Let's see why this is yelling at me here. Let's go ahead and fix that. Let's see, string and string. We should not have an issue. This one here, let's see if we need to drop that in some parentheses like that. this needs to be lowercase actually is what it's complaining about. So the beauty of this now is once this isReady function is done, in here we can simply say self.blocks.forEach, and we have the callback in, and we can say API caller shared. This should be capital, the API caller shared instance, and we're going to say get data, and we're just going to plumb the callback back into the completion handler. And essentially what we've done here is we have allowed this get data call to quote unquote pause, and we retain all those blocks in this array. And once our warm up is done, we go ahead and execute all those get data calls again with the respective callbacks. So let me add a print statement in here so we can get a better visualization in the console as to what's going on. So we'll say, maybe we'll say warming up. Inside of here, I'm going to go ahead and say maybe we'll say isReady. And then after that, we're going to actually see all of our print statements since we're doing this. And I'm going to go ahead and essentially do this a total of 3 times so you guys get an idea. And let's go ahead and give this a run. So I'm going to open up my console and hit this play button. And the very first thing we expect to see is warming up. Sometimes the playground decides to be a little finicky, so just bear with it if you don't see any prints. Let's make sure we're calling all of our functions. Looks like we are. API warmup, get data, get data, get data. And boom, okay, so we are warming up, and after 5 seconds, we expect to see isReady, and then these blocks are called. And boom, that's exactly what we see. Now, watch what happens if we don't account for, this blocks append, right? We're going to basically guard that it's not ready. And if I try to go ahead and call this again, obviously what's going to happen is because we're not hanging on to those blocks, it's just going to say, warming up, it's going to say isReady, and then we're never going to re-execute this get data call because we never hung on to these completion handlers. So this design pattern is fairly common. A good use case that I'll describe is when you're building out authentication, perhaps, you sometimes have to refresh a user's access token. However, every time you make an API call, it would be kind of silly for your caller side to say, hey, refresh the token or try to refresh it and then make the call. So instead, what we happen to do, or commonly do, is we obfuscate all the authentication refresh logic within some class. And every time we make an API call, that class internally will check, well, hey, do I need to refresh my token before I try to call this API? And if I do, I'm going to hang on to, the callback, the completion handler for whichever API call was just attempted. And then I'm going to come back and try to call it after the token has been refreshed. So without talking about more theory, let me go ahead and close this playground. Let's go ahead and create a new project, and then we'll do one more example, and this time we'll focus on the UI a little bit. So we're going to create a iOS-based app. I'm going to go ahead and call this a when ready example. So I've used the term when ready and OnReady in this video, and I did it in intentionally. You can use it for both types of design patterns, so you can wait for something to be ready, or if you have something like a refresh token, you can wait until it's ready because it might happen more than once. So let's go ahead and expand this. I'm going to go ahead and run our app in a simulator, and we'll do a pretty basic example. So our example is going to be in our view controller. We're going to first create a function to get color. So we'll go ahead and say get colors, just like that. And colors is going to return via a completion handler an array of colors. So we're going to say get colors. And actually, we don't even need to return it. What we could go ahead and do is simply say that this guy is going to assign colors to an array up here. So we'll go ahead and say colors will be UI color, and it's going to be empty by default. Similarly to our playground, we're going to artificially create some delay here by saying async after now +5. Now in here, we're going to say self.colors, and I'm just going to stick a bunch of colors in here. We're going to say system blue, maybe. We'll say system orange. We'll go ahead and say system pink, and that's probably sufficient for our example. And we are also going to go ahead and call a function here, play colors when ready. So play colors when ready. And this function is going to wait for the colors to be populated. And once the colors array is populated, we are going to go ahead and actually play the different colors or change the view color in the order of this array. So one thing that's really important with this pattern is you always need a completion handler. If you don't have a completion handler, there's no way to hang on to this call without blocking the thread, which generally is not a great design principle. So here we're going to say completion handler, and it's going to return to us an array of UI colors. So we're going to say UI color. This is going to return void, and we of course need a is ready property here. We'll say is ready by default, of course, is going to be false. And once we've assigned all of our colors here, we'll say self.isReady is true. And in here, actually, the other thing you could even do, and this is another way that I guess I'll demo this, is you don't even need to use isReady. What you could do here is you could say guard that your colors array isn't empty, which in our case, serves the purpose of we don't even have any colors right now, therefore it's not ready. If we do have colors, we'll just call completion and pass them back. So what do we do here? We want to hang on to this completion handler. So we're going to go ahead and say, and I haven't created the array yet, but we're going to end up saying blocks.append. It's going to be completion, and I'll stick that blocks array right here. It's going to be of the same type of that completion handler, just like that. And we should be good to go. So once we have this and our colors have been assigned, we can go ahead and simply say blocks, or self.blocks I should say, dot for each, and this is going to be self dot play colors, and we're simply going to pass in $0 as the completion handler. Now this guy's yelling at me because we don't have the callback here, the closure, so we'll say colors in. And what do we want to do here on the main thread? All I'm basically going to do is I'm going to actually loop over. So we're going to say for color in colors, we're simply going to change the background color with a slight delay, so we can always see the color for a moment before it switches to the next one. So we'll say now plus 1 second, and I'm going to go ahead and say self.view.background color is color. So hopefully that wasn't too complicated to follow. The meat of what we've written here is the fact that colors is empty by default. Maybe we would need to fetch the colors from an API, hypothetically. In this case, we're just adding an artificial 5-second delay. Then we go through our blocks. One thing you might also benefit from, which is a little redundant, but you could do if blocks isn't empty, go ahead and try to use all of them. And one really important thing that I actually did not call out in the playground is once you've invoked these blocks, it's really good practice to actually remove them. And the reason being is because the next time you try to call this, and let's say, colors isn't ready, we don't want to accidentally call the first completion handler that we stuck into this array. And finally, this function here, if we have colors, call the callback. If we don't have colors, hang on to it in our completion handler. So we'll go ahead and give this a run. I expect our background color to be white from the get-go, and then once we start to actually get ready, once we get the colors, in other words, we should start to see the colors play. Now, let's make sure that we actually have our app launched. Probably should have added a print, but that's all right. Let's be patient with it, and if it takes too long, we'll go ahead and add a print so we actually know, that the simulator isn't hung, that it's actually, waiting to be ready, quote unquote. So bear with my simulator here. Drop a like down below if you haven't done so already. Let me know in the comments if you guys use this design pattern. I use it pretty commonly personally in, my own projects and a lot of larger apps, etc., etc. So it looks like it is taking too long, so let's go ahead and see what's going on. I think I actually forgot to say get colors is what I probably did. Yep. So I forgot to say get colors, and actually to paint this example, we could actually say get colors after we make this call. So we're going to go ahead and throw a print in here also. I'm going to go ahead and say warming up. That way we'll always see something in the console so we're not losing our mind. So by default, our app is going to be, just a standard white or black based on the theme. And then once we have our colors, we should start rotating through them one by one. Let's see. So let's see, one by one. So it actually isn't one by one because we're just delaying it all here. So the better thing we can do is we're going to say for x in 1 up to We can say colors.count. We can go ahead and say this will be now plus, and we'll go ahead and say x plus 1. That way what's going to happen is every single iteration, we are going to increment the delay by 1 second. So we'll say time interval. This is going to be x. Let me add some spacing in here so it doesn't yell at me. So let's see, time interval. We don't need these extra parens. Let's try that one more time. Time interval. Sometimes Xcode autocomplete is the worst thing in the world. And sometimes I also just make a bunch of typos. So there we go, there's time interval, and here it's yelling because it doesn't know what colors is. It's going to basically be x minus 1. And let's see what else is going on. So let's see, self, view, background color. This should be colors, plural, since it's the array. Go ahead and run it one more time. 3rd time's a charm, and hopefully we should be good to go. This is just semantics at this point. You guys hopefully get the points. I just want the color to, appear for the sake of a complete example. So cool, so we start off with blue. We should go to orange momentarily, boom, just like that. And then we should go to pink, and we'll be good to go. So the point of this example, once again, OnReady, WhenReady blocks. Hopefully that made sense to all of you. If you enjoyed the video, drop a like down below. Looks like pink isn't showing up, and I'm not going to waste everyone's time with it. But thanks again for watching. I'll catch you on the next one.